Hello, we're back and we're looking at some integration, some differentiation. Last lesson we're looking at derivative rules and using simple rules. What we're doing now is we're going to be working out by calculating the equation of tangents and normals. So what are these equations of tangent and normals? So a tangent, and you probably would have heard of this when you're looking at circles before, a tangent is a straight line that touches a curve at one and one only point on that curve. So for instance, if we drew a point here, I could draw a tangent, and let's do this graph so it's like that, that's it. I could draw a tangent line so that it touches just at that point here. So a tangent line is a straight line that touches the curve at one point. So it's a straight line. Whoa. Straight. So it's a straight line that touches a curve at one point. Okay, so this here is an example of a tangent line. So for instance, we could say, well, the tangent when x is equal to 2. So we're going to say, well, this tangent line will touch the graph, the function, when x is equal to 2. So when it comes to tangent, the notation for finding the gradient of a tangent is notated by the gradient function, which is m, which is equal to lowercase or subscript t. In order to find these tangents, we have to differentiate the function of this curve first. Because what we're doing here is we're trying to find out the gradient of the equation of the tangent at x is equal to 2. So this here is what a tangent line is. And a tangent line could be at any point. I could have a tangent line that comes along here and touches it. Or a tangent line that touches here. Or a tangent line that touches here. So the tangent line could be any point on that graph where x is equal to a particular point. The normal is what we call the perpendicular line. So perpendicular. So for instance, if I said I wanted to find the normal at when x is equal to 2, well then this here is the perpendicular, so a 90-degree angle of that point. So this red line here would be your normal. Okay, so that's your normal, and this black line here is your tangent. So when we're coming to find the normal is always perpendicular to the tangent. So remember, perpendicular means at right angles. So when we're looking at normals, it has the notation of m, your gradient, subscript n. And it is the negative reciprocal of the tangent, or gradient of the tangent. So for instance, at this part here, if the gradient of the tangent this when x equals 2 was, let's say, 4, then the gradient, the normal when x equals 2, would be the negative reciprocal of that. Again, and if we had, say, for instance, the gradient of the tangent was equal to 2/3. So therefore we have the negative reciprocal. So the gradient, the norm, would be negative 3 on 2. So it's a negative reciprocal of this function. When we're looking at tangent and normals, when we calculate the gradients and when we calculate the equations, everything is exactly the same. except for when we calculate what the gradient point of the tangent and what the gradient point of the normal is. And we use that to help us calculate the equations of each of these things. Alright, next lesson or next video, we're going to look at some examples.